Let's do buffers. So this is the last part of the learning objectives of homework 3. So this is LO3, buffering. And there's a bunch of good stuff to talk about with this. This is, for better or worse, one of them topics where it doesn't take me too long to talk about it in lecture. I'll give examples and stuff and show you, to hopefully explain well everything that I'm talking about. But it's really up to the coding. Like, I can say what it is pretty succinctly, and then it's up to you to code. That's where it gets more challenging. As opposed to next week, I'm going to spend a whole week talking about WebRTC, because I got lots to talk about with it. But when it comes to the code, there's very little for you to actually do for WebRTC, for the application objective. So with that, let's get into it. Any questions before we get into it? LO2, yes. And then after today, LO3 as well. So after today, all 3 LOs for homework 3 are all in your hands. And aside from questions that you all have for me, I'm done talking about them. I won't have any lecture content pre-constructed or anything, except maybe next Friday, especially if there are common office hour questions. Next Friday is another examples lecture. The last lecture of every chunk of homework content is so maybe there I'll have a few examples, but really everything's going to be out there after today. All right, so reminder what a TCP connection is, which we just talked about WebSockets, so this is pretty fresh in our brains. A TCP connection is a connection that allows for streams of data. It's a full duplex connection, so streams of data from client to server and from server to client. With WebSockets, this is abundantly clear because we're sending information back and forth. With HTTP, we create a TCP connection. Client sends a request. We process that request, send a response, and then for our purposes, we just close the connection right there. We don't worry about the keep alive stuff and reusing the same TCP connection, at least for this course. Maybe in the future, students will have to do that, but y'all don't have to. But it is a stream of data. That's what we want to focus on today. It's a stream of data over the TCP connection. And so far in the course, we've been very careful for every single request, especially small GET requests, but every request, even the post requests for chat, registration, login, and for Objective 1 when we're testing with small images and WebSockets, the small chat messages, everything's been tailored to make sure that one read from the TCP socket, you go to the TCP socket, you say, you got some data for me? TCP socket coughs up the data, and that's your entire request. That will not always be the case, and after today, that's definitely not going to be the case. When you hit LO3 on homework 3, that's not going to be the case. You're not going to read the entire HTTP request or WebSocket frame by going to your TCP socket a single time. It's no longer a safe assumption. So just to capitalize, or just to emphasize what I'm even talking about, somewhere in your code you have this receive method. You're receiving and then some integer value. And that integer value, I think I said this a lot in lecture, so this should be familiar by this point. It's the question of what do we do about it. But that integer value says, read up to this many bytes of data from the TCP stream. So you create this TCP connection, and the client can send information at any time to you over that connection. And whenever there's data ready to be read, receive is going to return that data. So receive hangs, you get to this line of your code, your server's going to sit there on this line and do nothing. It's just going to stall and just wait. And then as soon as there's data to be read, as soon as there are bytes to be read on the TCP socket that the client sent to you, then it's going to return up to 2048 bytes of that data and then go through the rest of your code until, as we'll see today, until it hits receive again. Then it'll read up to 2048 bytes of data if there's any data ready to be read. But this is a stream of data that so far we've been treating as a kind of a message service. Like a client is going to send us a message in one big chunk. So we just assume we call receive of 2048 and we just get everything that the client wanted to tell us all in one go. And even when we have file uploads, our file uploads can be fairly small. For Objective 1, we have small images that we're testing with. where the full request is going to be less than 2048, just to make sure we can test your multi-part form parsing containing image uploads without worrying about buffering first. And remember, I'll emphasize this again since the slide wants me to, maximum number of bytes. At most 2048, that does not mean you will read 2048, even if the message you expect is greater than 2048. Because all the bytes might not be ready. They might not all be ready for you. So at most 2048. If somebody's sending a 2 megabyte request, you might not get 2048 on the first call to receive. Yeah.
In that case, what would the remainder of the bytes be?
It would be, so receive will return a byte array, and it'll be of the size of whatever you call it. It won't give you an array of size 2048 with empty bytes. It'll give you an array, if 10 bytes are read, it'll give you an array of size 10. So, of course, our question, hopefully it's foreshadowed enough. What happens when the files are big? What happens when they're larger than your TCP buffer size of 2048? What happens when you cannot read the entire request in one go? And especially what happens when we have very large files that we're uploading. We'll test with files that are quite large. We'll test in the megabyte range to make sure that you can handle arbitrarily large files. You should be able to handle gigabyte-sized files, but we're not going to sit there waiting that long during each test. But you should be able to handle gigabyte-sized files as long as we're not overflowing your memory entirely. Eventually, you're going to run out of heap space. So we're not going to hit that point. But we'll test with pretty large files to make sure that you're buffering the way we expect. So what happens when we have a very large file upload? So with this, what you can do, which don't do this, we check for this in the testing procedures. We're going to make sure you don't do this. But what we could do is just increase this number. We'll just make this number super huge. And I see students do this, and it frustrates me every time. That defeats the whole purpose. First of all, that's buggy. It's hacky, but it's buggy too. It's not going to work the way you want it to. And I'll demo that not working. I'll try it during lecture and show you that it doesn't even work. So you can try doing that, but it's not going to work. Like students will read the content length and then say receive content length. It doesn't work. Don't do that. We're looking for that too. Make sure you don't do that. That is going to break at some point, at some level. That's not how we write code. We want robust code that's always going to work. That is not always going to work. So we could, but no. This is a maximum. That's why I keep emphasizing that it's a maximum number of bytes. You could just put like 6 trillion right here, but it's a maximum number of bytes. You're not going to get up to 6 trillion bytes as long as that's how big the request is. It's not going to work. So we don't do that. I'm just going to leave it at 2048 for everything. In my solution code, it's 2048 still. We're not going to touch that number. There's no need to. So what we're going to do is call receive multiple times. We can keep calling receive. We can keep going back to the TCP socket and saying, hey, you got more data for me? Can you give me, if you have more data, can you give me up to 2048 bytes? And then just keep going back. Hey, can I get up to 2048 bytes? Hey, can I get up to 2048 bytes? And just keep going and going and going until we read all the information. That's what we want to do. We're going to read from the socket multiple times. This is a stream of data. We're going to keep going back to the stream and say, you got anything else for me? Got anything else for me? Got anything else for me? Until we get all the information that we want. So this is what we want to start doing, is buffering our inputs, buffering our reads from the TCP socket. When we read from the socket, we're going to get those bytes, which might not be the whole request. The slide really just repeats things I already said. So let's get on with it. But what happens when the whole request can't be read in one read, and we're reading from the socket multiple times? The user's sending a stream of data over to us, which might, for our purposes, will be a very large HTTP request that's being sent over this stream of bytes through the TCP connection. And what happens if we call receive and we're not getting the full request? One, the one we're going to see, the user's just sending a lot of data to us. It's more than 2K data. Well, we're not going to get it all. And what happens when the user has a slow connection? This is one of the things that will really catch up to you if you just start increasing your, receive 10 trillion. This is what's going to catch up to you is one of the things. Is what if the user has a slow connection where their internet is kind of crappy, it sends part of the image and then just sits there and can't, access the internet for a little bit and then sends the rest of the image. You're going to receive is going to return as long as there are bytes to be read. So that first chunk that got through, that's what you're going to read. Receive's going to return with that partial request. And then once the client's connection kicks in again, they're going to send the rest of the request. That's going to be sitting on the TCP stream. But if your solution is just jacking up that number on receive to have your TCP buffer itself for the library be larger, you're not going to get the rest of the information because you're only calling it once. You're trying to cheese everything. You're going to have a broken server. Clients are going to be very upset, and especially clients with slow internet connections. That's going to break for you. No, the server does not wait for the whole message. So TCP doesn't understand that we're using HTTP at all. It doesn't understand that the client's going to send a request and we're going to send a response. It's not going to understand anything of that. The TCP socket says, hey, there's bytes for you. Here you go. That's it. That's all it knows. It can't do anything else for you. Yeah.
So you're saying we can't bump up the number of the bytes that we receive. So in the apps that we're using daily, when we upload images or videos to it, is that exactly what they do? They read it in small chunks, or do they have a buffer that accepts everything in one time, and then we can upload it in just one go, and we don't have to read it?
They're like uploading a video.
Or
what?
Doesn't matter. Anything above the threshold.
Yeah, and any server is going to have to do buffering of some sort. Yeah, they have to. At some level in their code, they have to. Bless you. And then the ultimate of what if we want to stream data? You can't just sit there and call receive 10 trillion. Wait for the entire stream to end. Wait for the streamer to stop streaming and then process all that information. We can't do that. So we have to have some form of buffering, especially when we get to these kind of things. If you're streaming data, it has to be buffered because you want to read whatever's available, process it, put it available to all the users, read the next chunk, and keep going through like that. So we need to buffer. Buffering is a necessary thing, something we have to do. So we read at most, just in case I haven't emphasized it enough, at most, that number of bytes, which is 2K for our purposes for the handout code. I mean, if some of you change it to 4K, it's whatever. But as long as you're not cranking it up really ridiculously high. At most that many bytes, it's always been the entire request for this up to now in the course. But now with file uploads, what do we do to handle this? And let's get to what we do. We have multiple reads to receive. We know that much. We're going to have to call receive multiple times, but how many times? When do we stop? When do we know we got the whole request? And this is where content length finally becomes an absolutely critical header to read. You absolutely must read that content length. It's always been important for us to set the right content length in our responses, but if you've never checked the content length of a request up until now, you probably got away with that. You probably really didn't even have a reason to check them, to be honest, until now. Now what we're going to do is we get this HTTP request, and we're still going to make one assumption. We're going to assume that the first time you call receive, as long as you're at 2K or more, the first time you call receive, you will get all the headers. Not true necessarily in general, but in this course, I'm going to, that's a fine assumption to make. The first call to receive, you will get all the headers. You're going to parse the headers, get the content length, and now you know how many bytes of data you expect to receive. Now you're going to have a loop that keeps calling receive until you read that many bytes of data. So that's the core of the idea of how we're going to buffer. How do we know how much to buffer? Content length. Read content length number of bytes, and then you're done buffering. Before you read content length number of bytes in the body of the request, you're not done buffering. You need to sit there in that buffering loop and continue buffering. And then once you're done buffering, then you process the request. for the bytes you're reading.
The information that you're taking in, because like when you're buffering, you take in
A byte array. Like when you call receive, it's returning a byte array. Python makes this simple enough. You plus concatenate two byte arrays. So you just keep accumulating those. If you do receive data plus equals receive of 2K, it'll keep slapping it together and create this big request for you, big byte array. Yeah.
When the situation happen where you're like continuously reading from the TCP socket, and as you're reading, another request comes in. So like you're reading on the poster socket, another request comes in, and the headers from that other request are like directly after the content length, like, but you've already like taken like how those headers.
The short answer is no. Because we're using our TCP connections as one and done, we get a request, we send a response, and we close the connection. So we're not going to get a second request on that same connection. When a client wants to send multiple TCP requests, they'll create multiple HTTP requests. They're going to open multiple TCP connections with our server. So like when they want CSS, JavaScript, an image, that's 3 connections. And they're not, even if we use the keep alive, it's going to wait for a response. Once it gets our response to the first request, then it might reuse that TCP connection for the second request. So we wouldn't really have them mixed up too bad. So this is the crux of it, though. Read content length. You can assume you got the headers in one go. Read the content length. Buffer until you read that many bytes. So you can, I'll repeat it since I said it ahead of the slide, but you can assume that the first read, you're going to get all of the headers for the HTTP request. So you can assume read once, process all your headers. If you need to buffer, you're going to read the content length and check how many bytes you've read from the body. And if you haven't read the whole body yet, then you enter your buffering loop. If this wasn't an assumption, it wouldn't be too much more work, but you'd have to check. Read from the TCP connection, check if you have /r/n/r/n somewhere in the bytes that you received. If not, you're buffering headers. That would be the only change if you can't make that assumption, which wouldn't be too bad. And don't do this. We will look for this in the code. If we see this, we're going to make sure we test to expose that. You do have to have a buffering loop. We have to buffer WebSockets too. WebSocket frames for LO2, they have to be pretty small. That way you don't have to buffer your WebSocket frames. But when you're in that well true loop, it's going to be well true after you did the WebSocket handshake. Don't let that connection end. Well true loop like we talked about in the past 3 lectures, or at least 1 lecture. I think I didn't mention it in the first 2. But you enter that well true loop. First line is receive 2K probably. Some of you do different things here. You'll read a few bytes at a time, parsing the headers and everything. That's fine. But we're going to read from the TCP stream. We're going to parse the WebSocket frame headers. We're going to figure out what our what our payload length is for the WebSocket frame, and then buffer until we read that many bytes of payload. Once we've read that many bytes of payload, then we can demask all the payload, do all our WebSocket stuff, processing that WebSocket frame. Oh, this should say process the frame. It says process the request. So same thing with WebSockets. We're going to test with up to like 100,000-ish bytes. We're not going to hit that 131,000 threshold, but over 100,000 bytes in a single WebSocket frame. We're going to test with frames that large. You need to be buffering your WebSocket frames as well. So read in that well true, read from the stream, parse the headers. If you didn't read payload length number of bytes, enter your buffering loop until you've read payload length number of bytes, and then process the WebSocket frame. So this is buffering. It's in a nutshell. You're reading, checking how much you need to read, going in a loop and going to your TCP stream and keep reading that data until you read that many bytes. And then once you've read that many bytes, process the request or the WebSocket frame. So like I said, not too much to say in lecture. I think conceptually this isn't too difficult. When you go in the code, it gets a little trickier. Not overly so, I don't think so. But it's one of them things that I end up seeing a lot of little bugs in when students come to office hours with buffering issues. There's lots of little things that can go wrong. Or nothing goes wrong and you just get it on the first attempt. And then I never get to see you in office hours. But. Any questions on buffering? That's most of what LO3 is on homework 3. Large WebSocket frames, large HTTP requests. Yep.
So, for the WebSockets, you said sometimes people just read the whole thing at once, or sometimes just read byte by byte to parse.
Mm.
That's what I'm doing. And for the images, obviously you can't do that, right? Or can you?
No, because you don't know how many bytes to read.
Right, so we'll have to read as much as we can and get as much as this. Okay, let me formulate this. So if I have 2048, and if I submit a picture that is, let's say, 4,000, right?
Mm.
I'm going to read, let's say, 2,300 of it, 2,000 of it, and then get the rest in the second chunk, and then connect all of those together. And send back.
Yeah.
Is that how it's going?
Yeah, it won't be 100%. Like, that's not exactly how it's going to work. Because you might ask for 2048 bytes and only get 100 bytes. So you do have to enter a loop and have some checks to say, did I read enough bytes yet? When students start doing math and saying, okay, receive this many bytes because that's how much I expect left, sometimes that can go wrong if all the bytes aren't ready on the stream. Like especially for the last read. Usually this one actually doesn't get students in trouble, but like the last read, instead of doing 2048, doing 2048 minus, or however much left I have in the content link. There's really no need to do that. If you ask for 2048 and there's only 500 left in the whole message, the whole request, you're just going to get the 500. There's no need to do that, and it can potentially cause issues if there's like network lag at that moment, but I don't know. That one alone is fairly rare. But don't assume in general that every single time you read, if there's more than 2048, you will get 2048. That can start being a more dangerous assumption. Okay, anything else? Okay, there is one more caveat to WebSockets. So we don't, actually let me talk about why we don't have this issue with HTTP. I kind of just mentioned it answering a question, but just to make sure we're on the same page. HTTP, request, response. I get a request. If I ask for 1 trillion bytes in my loop, in my buffering loop, I say, give me 1 trillion bytes. And I buffer until I read content length number of bytes, whether 1 trillion's ready or not. I buffer and then process the HTTP request. What I don't have to worry about is a second HTTP request interfering with my logic there. I don't have to read 1 trillion and get like, when I'm just processing an image upload, I don't have to worry about somewhere in there getting mixed up with a request for my CSS or my request for my JavaScript or something. I really don't have to worry about that because that TCP connection is going to be a request, response. Even if we're reusing the connection, which we're not in this course, it would be request, response, request, response. They're not sending another request until I send them that response. So I don't have to worry about my messages getting mixed up or my HTTP requests getting mixed up and getting the wires crossed with that. I do with WebSocket frames. WebSockets, we're creating a TCP connection, upgrading it to a WebSocket connection, and leaving that single connection open for any number of WebSocket frames sent to the client or from the client. We can use that for multiple messages, and the client can send us multiple messages back to back. If the client wants to send us 20 messages all right in a row at effectively the same time, at almost the same time, they can do that. And if I go to my TCP socket and I say, give me 1 trillion bytes, I might get 10 WebSocket frames when I'm reading from that socket, because there's 10 frames ready to be read. So this we do have to care about with WebSockets, that multiple frames might be sent back to back. So we need to think about this one. When we read from a WebSocket connected, TCP connection that's been upgraded to WebSockets, we'll read a frame, we'll check the bytes, and we'll check the payload length and buffer until we read payload length number of bytes. But in that last read from the socket, we might get the headers of the next WebSocket frame. And this is something we need to worry about. So we don't just need to buffer to make sure that we read the full frame, but we need to check if we overshot. If we read more than payload length number of bytes, bless you. If we read more than payload length number of bytes, we know that those extra bytes are part of the next frame. We need to set those bytes aside, process the current frame, and then go back to those bytes that we set aside. That's the frame that we're processing, read those headers, buffer if we have to, and go start the process all over again. But what we need to make sure we don't do is throw away those bytes. We don't want to miss processing those bytes. One way to test for this, the way that is in the testing procedures and the way I recommend to do it, in the JavaScript in the front end, there's the code that sends a message. So when you click chat or whatever the button says, it'll send that message over to the server. And somewhere in there, there's socket.send the message in JSON. Copy that line and paste it I would paste it 5 times. Now, whenever the user clicks send one time, it'll send 5 identical frames. Well, not identical, they'll have different masking keys, but it'll send 5 frames to your server, and your server should be able to handle that and parse those 5 frames apart, treat that as 5 separate messages, and parse the headers of each of them properly. It's a requirement for LO3, but it's also critical for the application objective. I used to not have this requirement. I would mention it in class, but we'd never test for it. And then everybody's WebRTC, not everybody's, but a lot of students' WebRTC would be broken. Because WebRTC, we'll talk about it all next week, but WebRTC is going to use the WebSocket connection and send a lot of messages back and forth to negotiate the WebRTC connection. And those messages are going to be sent at a rapid pace, and you're going to have to tease apart those WebSocket frames to make sure you don't lose some of the information of one of those frames. So if you're not handling this, your WebRTC stuff is almost certainly going to be broken. So getting this down is going to avoid even having that potential issue on WebRTC stuff. And for either of them, just to kind of emphasize this, read the content length or the payload length, and then buffer till you read that many bytes. Remember that neither of these include the bytes for the headers. This is probably the first mistake anyone will make doing this. It does not count the bytes of the headers. So the content length, which intuitively, you kind of all know this because you set the content length when you're sending responses, but make sure you remember this when you're buffering to not just say, okay, if I've read content length number of total bytes, then I'm done buffering. Make sure you're not counting the headers in that calculation. It's everything after that first blank line. After that first /r/n/r/n, everything after that, that's what counts for payload length, for content length. And then for payload length, it's everything after the WebSocket headers, including the masking key. So everything after the masking key, literally what's the payload in the protocol, that's the only part that counts towards payload length. So making sure that you're not counting those headers, or else you're not going to necessarily read all of the bytes of your request. Sometimes your buffering is going to stop before it reads the entire request or the WebSocket frame. So make sure you don't count those header bytes. Make sure when you're saying, if I've read content length number of bytes, it's length of the body of the request, length of the payload of the frame, less than equal or less than content length or payload length. Don't count the headers. Okay, any other questions? Let's not close that in case I want to go back to it. Okay, let's demo this and really show what we're talking about. Here's my server we've been working with. It's very similar to the handout code. It's receiving. I do have this line, which we can get rid of this. We really don't need this. Printing out the connection, the length of the received data, and then the received data itself. And then I'm going to do my regular web server stuff, parse the request, and send a response. But after I send a response, instead of closing the connection, I'm going to enter an infinite loop and keep reading from the stream. And if I didn't get anything, that means the connection was closed by the client. So then I do need this check I'm going to return because I have nothing in here that says if the connection should be closed, let's get out of here. So if the connection is closed by the client, we're going to return. And then if I did read something, I'm going to print out who sent it and how many bytes of data they're sending, and print out the data that they sent. So what this will effectively do, and I removed the buffering from my actual code. What this will effectively do is if I get a request that's greater than 2048, I'm going to look at what the request is. And mostly what I'm concerned about here is how many reads to the socket do I need to read the whole request. So let's fire this thing up. Let's go to my site, which is broken. Adding an infinite loop to your server can sometimes break things. Shouldn't be surprising. I actually have to get the front end loaded, though. It might be the dumbest code I've ever written. Well, true, return. Okay, let's get the front end. Stop this. Get rid of this. Restart this. And now I can use my image upload. So let's start with a small image. Hopefully I can find one somewhere in here. Let's upload. I want it to be an image. The Autolab image. Looks good. Post that. And what I'm just showing the request, so I'm not actually processing the request. But I get a post request. I actually got 2048 bytes of data on the first receive, which isn't always the case. We should see examples as long as everything plays nice where that is not the case. I get all my headers. We know that we're going to see up to at least all the headers and this first blank line. We're going to at least see up to this first blank line the first time we read from the stream. We're safely making that assumption, at least in this course. And then the request is more than 2048 bytes. So if I can parse, I'm printing this as a byte string so I don't get my new line characters. I want to see the white space characters. But let's look through here and find content length. Content length is 1322. So we're going to have to read a few times from this TCP stream. First one, we got 2048, and this is what we got. We got into the file a decent amount. And then, oh, good, I like this. And then we received again from the same client. This should be, actually, I didn't check. 923. From the same client, we received 160 bytes. So not 2048. We don't always get 2048. We don't always get our buffer size. But we got some information here. Then from a different client, we got another request, a WebSocket request. And what even happened here? Well, true. Did I read this wrong? Oh, because content length is, I read that as 13,000. 1322. So yeah, we did get the whole request in 2 reads from the buffer. This was the rest of it, 2 reads from the TCP stream. So this was the end of it, and we got it in 2 reads. We had everything for that file. This will not always be the case, so let's go for a bigger image. Let's go for a 9K PNG. Post. And now what we should see, and thankfully we did, is the first time we read from the socket, and this is true in Chromium browsers only. This was one of the big differences we talked about with Chromium and Firefox. Opera, what I'm using being a Chromium-based browser, is that I got 886 bytes on the first read. Now this is a 9K file upload, so there's definitely more data. There's definitely 2K of data that's going to have to be read, more than that. And I'm saying give me up to 2K, but guess what? On the first read, 2K wasn't ready. 886 bytes were ready, so it returned with 886. And then while the browser's messing around with the file and stuff, what it did was send the headers, then mucked around with the file, went to my hard drive and all that stuff. And during that time, during that delay, my TCP code, my TCP library said, hey, you asked for data. There's data. Here's 886 bytes of data. There's nothing else on the buffer right now. And then like a millisecond later, it says, oh, wait, I got thousands of more bytes for you. And your code's already gone because receive already returned. Not technically here, but right here. Receive already returned and your code left. Your code left that TCP stream and is doing its thing, even though there's more information to be read. And then we hit the while true. Then we're going to get the rest. And what this is doing, it looks like my print lines are bleeding together. But what it did was send only the headers up until that first new line, that blank line character. So we did get the headers. We did get that new line character, that blank line sequence. So we can look for this, grab everything before it. Those are the headers. Parse the headers, look for the content length, figure out if we have to buffer or not. We can do all that in the first read consistently with any testing I've done with any browsers. And then we go into this loop, ask for up to 2048, and now we do have 2048 bytes. We have the whole file that's going to be sitting there waiting. We have 2048 bytes. We're going to read all these bytes. We're going to read another 2048 bytes, read all these bytes, which are all bytes in the file. We're going to keep going until we get to the end. The last one should be less than 2048. Last one we got 1081. So we're going to the TCP stream multiple times to get this single request. Hopefully I hammered that point home by this point. But let's try a few more things. Let me stop printing out the received data. We don't need to see the bytes of the file. That was enough to see that, hey, we are actually getting the bytes of the file. So let me stop printing those out. Let me send just the same file to show what output we're going to start seeing. I didn't restart the server. So I'm still going to print out the first request, or the first read. But then the next ones will just show the bytes that we received. So we had to go 4 additional times to the TCP stream and read 4 separate times, additional times after the first request that got the headers to be able to get our single image, or our single request. Actually, let me stop doing receive data up here too. Let me get the output in a more consistent format. Get rid of all of that. Do this. Upload an image. And we can see, yeah, I thought I was missing one. I believe is what happened. But these are the total reads from the TCP stream to be able to get this one request. Multiple times, we read the first one that contains the headers, get the content length, enter a loop, and keep reading and accumulating our bytes until the loop is over, or until we've read content length number of bytes. Okay, now let's see this with a bigger image. Let's crank this up now that we're not outputting everything. Let's go for this GIF that's almost a megabyte. Upload this thing. Make sure we get what we expect here, which is a lot of reads. A lot of reads. Last one is less than 2048. Most of them are 2048. And we actually saw something interesting up here. If we can get there. Oh, that's a different connection. I thought the first 2 reads were less than 2048. So the first one's still the headers, and then a whole bunch of buffering would have to be happening here. So you get the idea there, right? Any questions on that one? Yep.
Would increasing the amount of bytes you take in make your program noticeably faster? Like if you doubled that, would it make it faster? Because wouldn't it be faster if you did bytes?
I mean, maybe. I probably not noticeably. Maybe just because concatenating all those arrays might be expensive. But you could crank this up, which is the next thing I want to do. So student gets clever and says, let's just crank this up. I'm just going to read once, or maybe twice if it's a Chromium-based browser. Let's try it. So what actually does happen here? For how many warnings I got to back up. Post. Invalid argument. I went a little too far. Did I overflow an int there? I think I did. And I'm dumb. I got to put it in my buffer. So this is large enough that it could read that whole file. I'm over 20 million here. Could read that whole file. Am I? Let me make sure. Yeah, 20 million. So I could read this whole file in one read from the TCP buffer. In theory, what's actually going to happen, if you can tell by my tone, not that. So we're still not getting up to that. We're going to get something internal to the library. We're getting either 64K, 32K, or 16K, seemingly at random here. Sometimes not even one of those values. Here's 49,100, 49,204. We're getting a bunch of wacky stuff. Like, we're not getting up all the way up to that number. It's up to 20 million bytes. If there's not that much data to read, we're not getting that much data, and there's going to be a lot of internals that are going to determine how much we actually get. And I'm not going to worry about what the internals are of my TCP connection and how my browser is sending bytes and how it's chunking up the file and sending. I don't want to think about any of that, and I certainly don't want bugs because I misunderstand any part of that. So if you jack this up, it's still not even going to do what you want it to do. And if you're trying to rely on anything with that, you're going to introduce bugs into your system that aren't going to give you the behavior that you want. So I say don't do it, and we're going to check for that, but it doesn't even work. Like, it won't even do what you want it to do. If you're trying to cheese things like that. I don't feel like going over to Firefox because I have to remove my well true. I have to do the return again to load the front end or anything. But Firefox will give you parts of the image in the first request. You're going to read. It's not going to do the Chromium thing where it just sends the headers, then the file. It's going to give you part of the file with the first read. Some of you will have, it works in Chrome but not in Firefox. Hopefully before you submit, you'll fix this bug. And that's usually because you're reading the headers, treating that entire read as a string and converting parts of the image to a string when you're working in Firefox. But in Chrome, you don't have the same issue because Chrome is only sending the headers, and you can safely convert that to a string only in Chrome. So that's going to be a bug in Firefox where it says, can't decode this, it's not UTF-8. So make sure you're testing in both of them to make sure that you don't have a bug like that. And then the same thing, I'm not going to demo it, but same thing for WebSockets. It's the same idea, except you're doing it within that while-true loop. In that while-true loop, you're also going to have a buffering loop. And yeah, I forgot to answer this earlier. You don't need the if length of received data equals 0 at all. This is only because I'm not actually buffering. Like, if I was actually buffering and handling these requests, I would buffer until I read content length number of bytes, and then process the request, send a response, and then close the connection. I'm only doing this so I don't even know if I'd have errors if I got rid of this. But just because if the client closes the connection, I'm in a while-true loop, so there's nothing in my code that's going to disconnect. It's not going to do anything. So if the client disconnects, this is going to return 0. It's going to say client sent 0 bytes. Get back to the while-true. This is going to return, or an empty array, not 0. An empty array, client sent 0 bytes, and it's going to loop around forever until my CPU starts burning. So I just don't want that to happen. That's the only reason I have that. If I'm actually buffering and handling image uploads, I will not have that if length equals 0 return. That doesn't have to be there. And for WebSockets, you're just checking if the opcode is 8, and that's how you're gracefully closing the connection. As long as you're gracefully closing the connections, you should never have to do the if length of received data equals 0, then return. That shouldn't ever be there. That's just a hacky fix. It's not something that actually should be in the code. Shouldn't be in the server. Unless you have something broken somewhere, which is why I'm embarrassed I ever had this year in my lecture example. We only have a little bit of time left, but actually I did show this already in lecture, so maybe I don't have to show this again. But make sure you're only getting the first blank line character. Your body of your HTTP request with image uploads will have these blank line sequences, so don't just split on every instance of it. Make sure you're just looking for the first instance to make sure you don't break your stuff. I like to do it with finding the bytes and kind of doing this manually. A lot of you do split and then give it a second argument of 1 that says split at most 1 times. That works perfectly fine too. And since I had it open, since I was ready to talk about it, bit masking, this is your XOR operator. This isn't even actually bit masking, is it? This is your XOR operator. And if you want to mask, it would be your AND operator to actually mask those bits to get 00110000